Arc fault circuit interrupter, or AFCI, protection is indeed required for wall-mounted forced hot water heating units equipped with a blower. The National Electrical Code, or NEC, specifically mandates AFCI protection for many 120 volts and 240 volts branch circuits that supply outlets for devices installed in dwelling units. This requirement aims to enhance electrical safety and reduce the risk of electrical fires. Firstly, it is important to understand what an AFCI is and how it functions. An AFCI is a type of circuit breaker designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps, or arcs, between conductors, creating heat and potentially igniting nearby materials. Standard circuit breakers are designed to protect against overloads and short circuits, but they may not detect low-energy arc faults. AFCIs, on the other hand, are designed to detect these types of arc faults and quickly interrupt the circuit, preventing a fire. Secondly, it is crucial to know the specific NEC requirements for AFCI protection. The NEC Article 210.12 details the requirements for AFCI protection in dwelling units. It states that all 120 volts, single-phase, 15 amps and 20 amps branch circuit supplying outlets or devices installed in dwelling units must be protected by AFCIs. There are some exceptions, like, for example, the exception in 210.12. The allows the use of an outlet branch circuit AFCI at the first outlet in the branch circuit, but it still requires AFCI protection. Thirdly, consider the specific characteristics of a wall-mounted forced hot water heating unit with a blower. These units typically operate on 120 volts or 240 volts and are connected to a branch circuit in the dwelling unit. The presence of a blower motor introduces a potential source of arc faults, as motors can experience winding insulation breakdown or other issues that lead to arcing. Additionally, the location of the unit on a wall increases the risk of fire spreading to combustible materials if an arc fault occurs. Fourthly, understanding the code's intent is helpful. The NEC aims to provide a minimum standard for electrical safety. The inclusion of AFCI requirements reflects the recognition of arc faults as a significant cause of electrical fires. By mandating AFCI protection for circuits supplying outlets and devices in dwelling units, the code seeks to reduce the incidence of these fires and protect occupants. Fifthly, when installing a wall-mounted forced hot water heating unit with a blower, it is essential to verify the voltage and amperage requirements of the unit and ensure that the branch circuit supplying it is properly protected by an AFCI breaker. If the unit operates on 120 volts or 240 volts and is connected to a 15 amps or 20 amps branch circuit, AFCI protection is required. The AFCI breaker should be installed in the electrical panel and properly labeled. Sixthly, there are different types of AFCIs available, including branch/feeder AFCIs and outlet branch circuit AFCIs. Branch/feeder AFCIs provide protection for the entire branch circuit, while outlet branch circuit AFCIs provide protection only from the outlet where they are installed. While both types of AFCIs can be used to meet the NEC requirements, branch/feeder AFCIs are generally preferred as they offer more comprehensive protection. Seventhly, it's important to ensure that the AFCI breaker is properly installed and tested. After installation, the AFCI breaker should be tested to verify that it is functioning correctly. This can be done by pressing the test button on the breaker, which should cause it to trip. If the breaker does not trip when the test button is pressed, it may be defective and should be replaced. Eighthly, understand the role of a qualified electrician. All electrical work, including the installation of AFCIs, should be performed by a qualified electrician. Electricians are trained in the NEC and have the knowledge and experience to ensure that electrical installations are safe and code compliant. Attempting to perform electrical work without proper training can be dangerous and can lead to serious injury or death. Ninthly, AFCI breakers can sometimes nuisance trip, especially in older homes with existing electrical issues. Nuisance tripping occurs when the AFCI breaker trips even though there is no actual arc fault. This can be caused by a variety of factors, including loose connections, damaged wiring, or faulty appliances. If an AFCI breaker is nuisance tripping, it is important to investigate the cause and address any underlying electrical issues. Tenthly, keep up with the latest code requirements. The NEC is updated every 3 years, and it is important to stay informed of the latest changes. The AFCI requirements have been revised several times over the years, and it is possible that future editions of the NEC will include additional requirements or modifications. 11thly, remember that AFCI protection is not a substitute for proper wiring practices. While AFCIs can help to prevent electrical fires, they are not a replacement for safe wiring practices. It is still important to ensure that all electrical wiring is properly installed, maintained, and inspected. 12thly, when dealing with older electrical systems, it is crucial to exercise caution and consult with a qualified electrician. Older wiring may be more susceptible to damage and deterioration, increasing the risk of arc faults. In some cases, it may be necessary to upgrade the electrical system to meet current code requirements and ensure safety. 13thly, consider the benefits of whole house surge protection in addition to AFCI protection. While AFCIs protect against arc faults, surge protectors protect against voltage surges which can damage sensitive electronic equipment. Whole house surge protectors are installed at the electrical panel and provide protection for all circuits in the home. 14thly, it's beneficial to understand the limitations of AFCI technology. While AFCIs are effective at detecting many types of arc faults, they may not detect all arc faults. For example, AFCIs may not detect arc faults that occur in certain types of electronic equipment or in circuits that are not properly grounded. 15thly, ensure that all electrical outlets and devices are properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, which helps to trip the circuit breaker and prevent electrical shock. Ungrounded outlets and devices can increase the risk of electrical shock and fire. 16thly, regular electrical inspections are essential for maintaining a safe electrical system. A qualified electrician can inspect the electrical system for potential hazards, such as loose connections, damaged wiring, and overloaded circuits. Regular inspections can help to identify and address electrical problems before they lead to serious incidents. 17thly, understand the difference between AFCIs and ground fault circuit interrupters, or GFCIs. While both AFCIs and GFCIs are designed to protect against electrical hazards, they protect against different types of hazards. AFCIs protect against arc faults, while GFCIs protect against ground faults, which occur when electricity leaks to ground. GFCIs are typically required in wet locations, such as bathrooms and kitchens. 18thly, when selecting an AFCI breaker, it is important to choose a breaker that is compatible with the electrical panel. Different manufacturers use different types of breakers, and it is important to ensure that the breaker is designed to work with the panel. Using an incompatible breaker can damage the panel and create a safety hazard. 19thly, it is important to properly label all AFCI breakers in the electrical panel. This will help to identify the circuits that are protected by AFCIs and make it easier to troubleshoot electrical problems. The label should be clear and easy to read. 20thly, encourage homeowners to familiarize themselves with the location of the electrical panel and the function of the circuit breakers. This will enable them to quickly shut off the power in the event of an emergency. Homeowners should also know how to test the AFCI breakers to ensure that they are functioning correctly. 21st, be aware of the common causes of arc faults. Arc faults can be caused by a variety of factors, including damaged wiring, loose connections, overloaded circuits, and faulty appliances. By understanding the common causes of arc faults, homeowners can take steps to prevent them from occurring. 22nd, when using extension cords, it is important to use the correct size and type of cord for the application. Overloaded extension cords can overheat and cause arc faults. Extension cords should also be inspected regularly for damage. 23rd, encourage homeowners to unplug appliances when they are not in use. This can help to save energy and reduce the risk of electrical fires. Unplugging appliances also prevents them from being damaged by voltage surges. 24th, consider the use of tamper-resistant receptacles, or TRRs, especially in homes with young children. TRR have shutters that prevent children from inserting objects into the receptacle, reducing the risk of electrical shock. 25th, when replacing electrical outlets or switches, it is important to use devices that are rated for the voltage and amperage of the circuit. Using devices that are not properly rated can create a safety hazard. 26. Ensure that all electrical boxes are properly covered. Open electrical boxes can expose live wires and create a shock hazard. Covers should be securely attached to the boxes. 27th. When working around electrical equipment, it is important to use insulated tools. Insulated tools can help to protect against electrical shock. 28. Encourage homeowners to contact a qualified electrician if they have any questions or concerns about their electrical system. It is always better to err on the side of caution when it comes to electrical safety. 29th. Consider the age of the electrical system. Older electrical systems may not have the same safety features as newer systems. If the electrical system is more than 25 years old, it may be time to have it inspected by a qualified electrician. 30th. Understand the local electrical codes. Local electrical codes may have additional requirements that are not included in the NEC. It is important to comply with all applicable codes. 31st. Remember that electrical safety is everyone's responsibility. By following safe electrical practices, everyone can help to prevent electrical accidents and fires. 32nd. Regular maintenance of your home's electrical system is essential for ensuring its safety and reliability. This includes checking for loose connections, damaged wiring, and other potential hazards. 33rd. Proper ventilation is crucial for electrical equipment. Overheating can damage electrical components and increase the risk of fire. Make sure that electrical equipment is not blocked or covered. 34th. When purchasing new appliances, look for appliances that are certified by a reputable testing laboratory such as UL or ETL. These certifications indicate that the appliance has been tested and meets safety standards. 35th. Consider installing smoke detectors in every room of the house, especially near bedrooms. Smoke detectors can provide an early warning of a fire, giving occupants time to escape. 36th. Develop a fire escape plan and practice it regularly with the family. This will help everyone to know what to do in the event of a fire. 37th. Keep flammable materials away from electrical equipment. This includes paper, cloth, and other combustible materials. 38th. Avoid overloading electrical circuits. Overloading can cause the wires to overheat and create a fire hazard. 39th. Do not run extension cords under rugs or carpets. This can damage the cords and create a fire hazard. 40th. Be careful when using electrical appliances near water. Water conducts electricity and can create a shock hazard. 41st. If you experience any electrical shocks, contact a qualified electrician immediately. This could be a sign of a serious electrical problem. 42nd. If you smell burning plastic or see smoke coming from an electrical outlet or appliance, shut off the power to the circuit and call the fire department. 43rd. Never attempt to repair electrical equipment unless you are qualified to do so. Electrical repair should be performed by a qualified electrician. 44th. Be aware of the signs of electrical problems, such as flickering lights, dimming lights, and outlets that are warm to the touch. 45th. If you are planning to do any remodeling or construction work, be sure to consult with a qualified electrician to ensure that the electrical system is adequate for the new work. 46th. If you are buying a new home, have the electrical system inspected by a qualified electrician before you close the deal. This can help you to identify any potential problems and negotiate repairs with the seller. 47th. If you are selling your home, it is a good idea to have the electrical system inspected by a qualified electrician before you put the house on the market. This can help you to avoid any surprises during the home inspection process. 48th. Remember that electrical safety is an ongoing process. By following safe electrical practices and maintaining your electrical system, you can help to protect your family from electrical hazards. In summary, wall-mounted forced hot water heating units with blowers generally require AFCI protection to meet current NEC standards and enhance electrical safety.